So the other day, I was watching Philhouse on Twitch. Philhouse has been streaming a really awesome series, playing the Japanese and North American releases of the same game at the same time, and discussing the localization differences. Philhouse has recently been playing Super Mario RPG, and during a recent stream, this happened.
Wait! Wait, what the fuck? Why? Wait, are you seeing this? Is this supposed to happen? Why is the mushroom lamp like this in the Japanese version? What the fuck? That doesn't seem right. Is that glitched?
This, of course, left everyone in chat amused and a little bit befuddled. The first thought that arose was that it might be an emulator problem. Although it's pretty rare for emulator inaccuracies to cause steps to be completely skipped or inserted while executing SMRPG's internal scripts, which are primarily responsible for controlling the behavior of room objects. I booted up a Japanese copy of Super Mario RPG on my Super Nintendo and verified that this does indeed happen on console, only on the Japanese version. SMRPG is not exactly known for having a lot of glitches and oversights, so this is pretty intriguing. I had to get to the bottom of this. In order to explain why I decided to take the next steps that I took, it's important to explain a few things about how objects are defined in Super Mario RPG. Essentially, you have 5 important concepts that work together to produce a thing that you can interact with in Super Mario RPG. Sprites, NPC definitions, room objects, event scripts, and action scripts. A sprite in Super Mario RPG is a collection of 1 to 32 raw graphical assets. These assets can include things like the frames of a character's south-walking animation, their north-walking animation, as well as any other actions they may need to perform in the game. These collections can each also include up to 16 animation sequences, which are usually used to define which of the 32 static images, and in which order, belong in a walking animation, or a walking animation in a different direction, so on and so forth. Sometimes, a sequence will consist of only 1 frame, and it'll just display the sprite as a static image. There are 1,024 sprites in the game, and they're used for everything from interactive objects in a room, to ending credits characters, to even the 4-button HUD that appears over your character in battle. Another example of a sprite is the lamp that we saw in the Marrymore Suite, which consists of only 1 asset. The first sequence is an example of a sequence that just contains 1 frame. It's why the lamp just stays still and can't do anything else. Another example of a sprite is the bellhop kid from the same room, which has 10 usable frames, and has a defined animation for walking south, and a defined animation for walking north. An NPC definition is a little more complicated. Some characters, like Toad or Valentina or Booster, to name a few, are used in more than 1 room in Super Mario RPG. It'd be wasteful to repeat a ton of code to define these characters in every single room they get used in. NPC definitions help to solve that problem. They pretty much define a character and how it should interact with the game's graphics memory and the room's collision data. These properties tend not to change room to room for the same character most of the time, so NPC definitions provide a convenient way to reuse the same character from room to room and trust that they will behave consistently. Each NPC definition takes on exactly 1 sprite. An example of an NPC definition is the bellhop kid again. He uses sprite 116, which we looked at before. He has a height of 7, which means if you jump on his head, Mario's position above the ground looks realistic for the sprite he's standing on. If his height was much higher, it would not make much sense. In some cases, the NPC definition properties determine how each of the sprite-specific animations will be used. More on that later. A room object is probably the most straightforward. In each room, you can have up to 28 interactable objects. Each of these interactable objects takes exactly one NPC definition. They also have some other properties, such as which direction they should face when the room loads, whether they should face you when you talk to them or not, and things like that. In the Marrymore suite, the first object in the room, NPC 0, is the bellhop, and NPC 5 is the lamp. You could have multiple bellhop toads in this room if you wanted to, and they could all use NPC 116. The room object is basically an interactive container for the NPC definitions we talked about earlier. And these are what you specifically interact with while you play SMRPG. Event scripts are like the instruction manuals for everything that can happen in a room. They execute when you load a room, step on a specific tile, or interact with most objects. In fact, every object in a room gets to have one event script that plays out when you interact with it. Examples of this can be simple. Talking to an NPC and having them just say a piece of dialogue to you is a simple event script, but still an event script. The lamp's event script prompts you to turn off the light. Finally, action scripts are similar to event scripts, in that they're an instruction manual for something that happens in a room, but they are only used to perform animations on an object and are independent of your interactions with them. Like event scripts, every NPC in a room gets one action script. Action scripts can include things like how this bellhop just walks in place when he's in a neutral position. So now that we have established exactly how NPCs work in the game and all the properties that are important to consider when investigating anything relating to an NPC, it's time to get into how we compare the Japanese and North American versions of the game. My initial suspicion was that one of the properties on the lamp object in this specific room might be wrong. Luckily, there has already been significant reverse engineering work done on SMRPG, with public documentation as to which sections of the game ROM some of the game's data lives in. You can find that information on romhacking.net, and I'm going to leverage it in a hex editor to go hunting for discrepancies. So the first thing that I decided to do was a direct comparison between the two games of all the room object bytes. I thought maybe there was a difference in the bits set on that lamp between the two versions that might point us in the right direction. No dice. Of course, that would just be too easy. I decided to check the NPC definitions next. Also, exactly the same between the two versions. So, thirdly, I knew that it probably wasn't a difference in the sprite data, because your in-game actions can't affect raw images or their sequence definitions. But I decided to check it anyway. And once again, they are exactly the same between the North American and Japanese versions. So, that just leaves event scripts and action scripts as further areas that could possibly present the problem. Event scripts and action scripts are pretty close together within the ROM, so I did a side-by-side comparison of the two games to see if anything jumped out immediately. It's mostly understood by the community that there are very few, mostly negligible differences between the two versions. But were we about to be proven wrong? Sort of. The big red block up in this summary of differences on the left here means that there's a whole bunch of differences between the two versions very early on in the event scripts. But a lot of these differences come from what's called a pointer table. A pointer table is basically a table of contents for Super Mario RPG's 4096 individual event scripts. It denotes where each individual script starts. So this way, if talking to an NPC is supposed to initiate script number 273, for example, the game knows exactly where to find that script by looking at the 274th entry in the pointer table. 274th because we're using zero indexing here. meaning the very first script in Super Mario RPG is number 0, and the 274th script in SMRPG is number 273. This means that we have to go to 1E0FAA. 1E because event scripts have to have the highest byte always be the same as where the pointer itself was found. So the pointer itself was found at 1E0224. That means that the event script itself will also start with 1E as its location. And then 0FAA, not AA0F despite it being written like that, because in event script pointer tables, the lower byte of a 2-byte value is stated first. This is called little endian format, and SMRPG uses it a lot under the hood. So, why am I telling you this exactly? Well, let's have a look at our game comparison again. A lot of this code in the highlighted area is basically exactly the same, but something strange happens immediately after the highlighted area. In the North American version, these 3 bytes, 084000, don't exist in the Japanese version. In fact, if you look after those 3 bytes in the North American version, the numbers continue on basically in exactly the same way as the Japanese version. The implication here is that the North American version has an extra command in it that the Japanese version does not. So why is that important? Because it means that one of these events will be slightly longer than the other, which also means that the pointer for the event after it will be slightly shifted down. We can see this if we go back to look at the pointer table. The next event, event number 274, now has a different pointer between the 2 versions, whereas the pointer for event number 273 was the same. That also means that every pointer after this will also be shifted down in the North American version. These are going to the same event, but in different versions. And that means every command outside the pointer table that jumps to another specific command after this point will also be looking for a location in the ROM that's been slightly shifted down in the North American version. Which means we have a whole lot of bytes that are going to be reported as different when there's only one small change. The comparison that we just saw showed us a lot of differences, even when those differences are not meaningful. So all that is to say, a byte-wise comparison will not be sufficient here to tell us what's really going on. Luckily, the Lazy Shell ROM editor can present each event command in a way that is at least somewhat human-readable. More so if you have a little bit of a background in computer science, whether professional or hobbyist, but for a lot of the commands, you can kind of get an idea about what's going on under the hood. For example, it's pretty obvious what run dialog means. It's probably less obvious what memory 7082-bit0 means, but with a little trial and error and just reading through some event scripts, you can eventually figure out what some things like this are really doing, especially if you have good knowledge of the original game. One thing that the Lazy Shell event editor can also do is to dump the entire contents of the event scripts or all action scripts to a text file. So if we could get a detailed dump of the event scripts in the US version and a detailed dump of the event scripts in the Japanese version, and use a program to compare them side by side for a more detailed look at the differences, that would help us narrow down what might be going on here. Lazy Shell can technically open and analyze a Japanese ROM, but it's not really built to preview any Japanese dialogue. And the dialogue is different between the Japanese and North American versions, which means that when comparing a dump of all event scripts, that would register as a difference when performing a comparison, which is not a meaningful difference that we want to have to pay attention to. And that's not good. So, for the purposes of a more accurate side-by-side comparison, I took the event and action scripts of the Japanese version and dumped them over a copy of the North American version. Just to make sure that Lazy Shell is going to dump essentially the same preview for both versions, with the only differences being discrepancies that are actually between just the event and action script portions of the game. So, I now have a text version of the event and action scripts from both the Japanese and North American versions. Time to compare them. I opted to try action scripts first because it's way smaller, but I didn't really find anything useful for our purposes here. The only big difference that I found was on a script that only ever gets applied to Mario, and the insertion of that script meant that all references to other specific commands were shifted a bit in the North American version, as we previously talked about when we were looking at byte comparisons. At least in a program like KDiff3, it's immediately obvious from highlighting when something is a big difference versus just a slightly adjusted pointer. It's interesting and may be worth an investigation in the future, but has nothing to do with our lamp. So, down to the last thing left to check, event scripts. This is a lot of code to sift through and compare, as you can see by the progress bar on the bottom right. But luckily, we find something interesting almost right away. This script has an extra command applied to an NPC in the North American version that isn't in the Japanese version. And from nearby other commands, it looks like this might be taking place in the Merrymore Suite. If we look at all of the contents of the script 273, it includes dialogues from inns from all around the world. Many of the innkeepers share one event script, but other factors such as the room you're currently in will change which parts of the script run and which ones don't. This was an interesting way to configure this because there is quite a bit of repeated code between inns, such as the screen shrinking down to a circle mask on Mario, Mario doing his peace sign pose, the sound effect playing, waking up in a bed to birds chirping, etc., etc. So, I think we're onto something here, considering that the lamp flip happens when you wake up in the suite. Let's look at this command. This is targeting a specific NPC within the room and making it load a specific sprite sequence. As we discussed earlier, a sequence is a predefined rule for one way the game can display the image assets that are associated to an NPC. So what this is doing is forcing it to load the default sprite sequence associated to NPC 5. Optionally, this command can indicate that the sprite should be mirrored from its default display, which is not happening here, but that is important to remember. So, I think we may be onto something here, because as we saw earlier, NPC 5 in the Merrymore Suite is this lamp. So, what does this mean for us? Despite the fact that this is a discrepancy of only one missing command, there's a lot to talk about here. I'm going to start off by having a look at this lamp again. You'll notice that in its default sprite frames, it faces to the right. This is actually unusual for sprites in SMRPG. If we look at every other character, they all face to the left. This actually matters when we go to investigate the properties of this lamp NPC. Every NPC placed within a room has a mandatory property that sets the direction it should be facing every time the room loads. The bellhop is clearly facing northeast, for example, but the lamp is defined as facing southeast, but it looks like it's facing southwest. So, why is this? Well, the answer boils down to, as far as graphics are concerned, radial directions in SMRPG for NPCs aren't really real. That sounds clickbaity. What I really mean is that assigning an NPC a direction when it comes to drawing the sprite is ultimately just a 1-bit alias for picking which of its sequences to load. Generally, looking at the bellhop here, if I pick southwest, it will show the bellhop loaded with sequence 0. If I pick southeast, it shows the bellhop with sequence 0 but mirrored. Likewise, if I pick northwest, that would load the bellhop as having sequence 1, and if I pick northeast, the bellhop shows is sequence 1 but mirrored. This is a simple assumption within SMRPG that is mostly consistent. As we discussed earlier, most of the characters are facing southwest in sequence 0 and northwest in sequence 1. We can see that with almost every character in the game. It's a clever way that the game saves space while offering another level of diversity and uniqueness to how its objects behave. Characters like Toad, who can face 5+ directions, or Mario, who can face 8 directions, expand upon this concept, but I won't get into that in this video. Another interesting perk that this particular feature has is that there are some characters who do not have north-facing sprites, such as the Axum Rangers. In fact, if we look at Axum Red's NPC class definition, he is explicitly defined as only being able to face southwest or southeast. So, if I tried swapping the NPC definition of the bellhop to use Axum Red instead of a pink toad, while it's facing northeast, and northeast is really just a sprite mirror, it still mirrors his sprite, even though he can't face north. This is just further evidence that NPC radial directions are effectively just shortcuts to load sequence 0 or 1 and mirror it or don't mirror it. Pretty cool, huh? So, why does this matter for the lamp? Well, since we know that southeast really just means mirror sequence 0, let's look at our southeast-facing lamp. It is, in fact, just a mirror of the sprite's default sequence, which for reasons unknown had its raw image asset drawn as facing to the right as its default, instead of to the left. As far as SMRPG is concerned, this lamp actually is facing southeast. The game did what it was told. It was told southeast, and it flipped the lamp's default sequence. So why is it that when we enter the room at first, the lamp is facing the correct direction? This happens because of a room loader event. Every time you physically enter room 12 from the hallway, it runs event 613. One of the first things it does before it fades the room in is it forcibly sets sequence 0, unmirrored, on the lamp NPC. Doing this overrides the lamp's direction that it is forced to face by its direction in the room definition. It forces it to load sequence 0, which, as we know from the sprite data, is the lamp facing to the right. Now, finally, why does the direction flip when we go to sleep? Well, let's go back to that script discrepancy we found earlier. Event 273 is the event that runs when Mario sleeps in the bed. The specific code of the script that controls the Marrymore suite reloads room 12. But here's a specific thing to note about the room reload command. When you force a room to load via an event script, you have the option of actually skipping the script that's supposed to run when that room loads. And that's exactly what happens here. This line of code explicitly instructs the game to reload the suite, but not to run the suite's loader event. 613, the one that we saw earlier, included a line to force the correct lamp sprite. This is so that none of the logic pertaining to the bellhop showing you around or anything like that will start running unexpectedly. But that also means the one line that makes the lamp face the correct direction is also not going to run. So the devs intended for that to happen right here at these next lines. So, as we see, the North American version remembered to still flip the lamp when Mario wakes up in the suite. The Japanese version did not. And that's it. That's why the lamp flips itself around in the Japanese version. The lamp's default sprite faces right instead of left, directions aren't real, southeast means southeast unless you're a lamp, and there was a simple oversight in the Japanese version of forgetting to override the lamp's direction with its intended sprite that was corrected in the North American version. So if you followed all that, you may be wondering, why didn't they just set the lamp's direction to southwest and not have to worry about override commands that need to be run in multiple places? That's the last fun thing we have to talk about here. Mario's jump animation to flip the light only really makes sense if he's standing in front of the lamp, so the lamp NPC can really only be interacted with by pressing A from the front. That's why the lamp NPC has to be listed as facing southeast. This is where direction is truly a real thing. Graphically, directions are just aliases, but as far as interacting with objects go, they can be functionally important in situations like this. So because facing southeast makes the lamp draw a sprite that looks to be facing the wrong way, the devs had to insert a command that does a sequence override to make it look more natural. And that's it! I hope you learned something today from this video. If you're interested in learning more about Super Mario RPG modding and mystery solving, be sure to sub to my channel and check out some of the resources in the description for this video. You can find a couple of Discords where you can discuss topics like this with other people who are just as interested as you.